A transmission line is used for the transmission of electrical power from generating substation to the various distribution units. It transmits the wave of voltage and current from one end to another. The transmission line is made up of a conductor having a uniform cross-section along the line. Yarn acts as an insulating or dielectric medium between the conductors. For safety purpose, the distance between the line and ground is much more. The electrical tower is used for supporting the conductors of the transmission line. Towers are made up of steel for providing high strength to the conductors. For transmitting high voltage over long distance, high voltage direct current is used to the transmission line. If we talk about the types, in transmission line, determination of voltage drop, transmission efficiency, line loss, etc. are important things to design. These values are affected by line parameters R, L and C of the transmission line. Lengthwise transmission line are three types: short transmission line, medium transmission line and long transmission line. If we talk about short transmission line, it requires a length less than 80 kilometers or 50 miles, voltage level less than 69 kilovolt, capacitance effect is negligible, only resistance and inductance are taken in calculation, capacitance is neglected. In medium transmission line is classified as a transmission line with a length more than 80 kilometers or more than 50 miles but less than 250 kilometers or 150 miles. Operational voltage level is from 69 kV to approximate 133 kV. Capacitance effect is present in medium transmission line and distributed capacitance form is used for calculation purpose. Now we'll talk about long transmission line. A long transmission line is classified as a transmission line with a length more than 250 km or 150 miles and voltage level is about 133 kV and its line constant are considered as distributed over the length of the line. The performance of transmission line depends on the parameters of the line. The transmission line has mainly four parameters such as resistance, inductance, capacitance and shunt conductance. These parameters are uniformly distributed along the line. Hence, it is also called the distributed parameter of the transmission line. The inductance and resistance form series impedance, whereas the capacitance and conductance form the shunt admittance. In this picture, we can understand it very easily. Let's talk about line inductance. The current flow in the transmission line induces the magnetic flux. When the current in the transmission line changes, the magnetic flux also varies, due to which EMF induces in the circuit. The magnitude of the inducing EMF depends on the rate of change of flux. EMF produces in the transmission line resist the flow of current in the conductor, and this parameter is known as the inductance of the line. And if we talk about line capacitance, in transmission line, ER acts as a dielectric medium. This dielectric medium constitutes the capacitor between the conductors, which store the electrical energy or increase the capacitance of the line. The capacitance of the conductor is defined as the presence of charge per unit of potential difference. The capacitance is negligible in short transmission lines, whereas in long transmission line, it is the most important parameter. It affects the efficiency, voltage regulation, power factor, and stability of the system. In shunt conductance, ER acts as a dielectric medium between the conductors. When the alternating voltage applies in the conductor, some current flow in the dielectric medium because of dielectric imperfections. Such current is called leakage current. Leakage current depends on the atmospheric condition and pollution like moisture and surface deposits. Shunt conductance is defined as the flow of leakage current between the conductors. It is distributed uniformly along the whole length of the line, and the symbol Y is represented it, and it is measured in Siemens. If we talk about the performance of transmission line, the term performance includes the calculation of sending end voltage, sending end current, sending end power factor, or loss in the line's efficiency of transmission, regulation, and limit of power flows during steady state and transient conditions. Performance calculations are helpful in system planning. Some critical parameters are explained below. Voltage regulation. Voltage regulation is defined as the change in the magnitude of the voltage between the sending and receiving ends of the transmission line. If we saw the law, voltage regulation in percentage is equal sending end voltage minus receiving end voltage divided by sending end voltage into 100%. By this law, we can easily find out the voltage regulation in percentage. Now, let's move to the next, the efficiency of the transmission lines. Efficiency of the transmission line is defined as the ratio of the input power to the output power. So if we saw the law, the transmission line efficiency in percentage is equal power delivered at receiving end divided by power sent from the sending end into 100%. So this is how we can find out the efficiency of the transmission line.